Hi everyone, so this is going to be an interesting video. We are just going to go through some assembly code and try to understand some of the fundamentals of it. So before delving into the code, let's briefly understand what is assembly code. So we all know that we write the code in the programming language like C or Java, but we write the code in English syntax. But the CPU, the computer, doesn't understand the English syntax. The CPU only understands the binary. So this binary code would be written purely in binary and we won't be understanding it. So this code is typically called as machine code. Now, when we started the programming in late, way back, way decades back, so the C and C++, Java, these programming languages didn't come up first. The first programming languages that came up were more related to the machine code, and they were more of a representation of a human readable format of the machine code. Now, one of those languages, one of those programming languages is assembly language. So assembly language is still a low level language that interacts with the hardware at very low level, and it is a kind of a human readable representation of the machine code. In fact, the even the programming languages like C first compiles to assembly, then to machine code. Now, depending on the compiler, the programming language might first compile to assembly code, and after that, it might compile to machine code, or directly it might compile to machine code. Now, having said that, we will simply write a simple hello world assembly code and just simply go through over it. Now, before that, you will have to do some installation setup. So I'm using a Linux machine. So first, just check your CPU information. It should be x86. Most of the Linux machines have the same configuration. It is uname space a. So yeah, I am looking for this x86 64 architecture. So after that, you simply have to follow this command, that is install NASM. So NASM is a compiler for assembly. Just install it. I have already installed it, and now these three commands are typically to run the Hello World program. So I have already written an Hello World program here, and we'll just go through over it. So yeah, let's get started. So the first thing that we are being told here is section.data. So section.data is a directive in the assembly code, and this simply tells us that this is the section where we can declare our variables. So this is what section.data tells us. This is the area where we can declare our variables. So after this, we have section dot text. Now, how we are defining the variables and everything here, I'll come to that, but I'm just going through all the sections. So section dot text is basically the main area, or you can say the area where I can write my code instructions. So this is the area where I can write my code instructions. Now, what I'm writing here is a global start. So global start, if I give you an analogy, it's kind of similar to what you have main in other languages like Java or C or C++. So global start tells, in assembly, tells that this is the start, this is where it's going to start, and this is where we are going to write the instructions. So this is where the code will be written eventually, and this section.text basically tells us, okay, this is the start area where the code instructions have been written. You just refer to this. Now coming back to section.data, how we are defining the variables. So your first area, that is the text, this is the name of the memory address. Now this could be anything. I can name it maybe address or something. I have just named it as text here. So this is the name of the memory location where I'm going to put up this data. Now db stands for not database. Here it stands for define bytes. So I'm telling here that I'm gonna define the bytes here. So after this, whatever is there, every character is a single byte. So I'm defining here hello world. So I'm defining here, let's see, 1, 2, 3, 4, 5. Space is also a byte, 6, 7, 8, 9, 10, 11, 12. Okay. So there would be 12 bytes. And after that, this 10 stands for the new line character. Okay. And I think this assembly also takes the code as a byte. So this will be one more byte. So it will be total 14 bytes. Okay, now this 10 is the new line character. So this is how I'm defining my data, how I'm defining my variables over here. Okay, now let's come down to how the code is written. So before we get into the code, let's understand what are registers. So now this is a very deep topic in the CPU architecture, but describing it briefly, these are temporary memory locations uh, wherein the data is stored. Now, if you want to know very detail in it, you will have to read about the CPU architecture, what is the exact purpose of registers. But for the scope of this program, let's just understand that these are just the memory locations wherein the data can be stored. So now there are different types of memory registers. So one of them is racks, and there is RDI, there is RSI, and there would be RDX. So these are typically the registers that we'll be referring over here. So now MOV stands for move. So I'm moving a value into this register. So I'm into the racks, I'm moving one. So if I move one to the racks, what basically it tells us, so the code is in a way telling the kernel that a write command is coming. Now this is called a syscall. So syscall is basically way for a program to communicate its instructions to the kernel. So this is the sys command, and here this one. So there's a list of syscall commands. So this one is typically saying to the kernel that a write command is gonna come. Now, same way, I'm gonna move one to the RDI register. So this RDI register is gonna tell that a write command is coming for the output. Now, this output could be on the terminal or it could be on the file. Okay. Now the next one is RSI. So here move RSI text. Here I am moving this memory. So whatever variable has been stored in this text, I am moving it over to RSI. That means over here I am moving hello world over here. So I move the actual variable, actual data from the memory to RSI register. And RDX, I'm telling it how many bytes needs to be output. So here I'm mentioning it as 14 bytes. And after that, it's syscall. Syscall means I'm saying that this is the syscall that we need to communicate to the kernel. Okay, after that, once this code is executed, I am moving 60 to racks register. After this syscall is done, now, what this syscall tells is assembly program should quit now. This is the end of the program. Now, the program should exit itself. And RDI, I'm just making it zero. So zero is for read only mode. So before exiting the program, I'm setting the RDI to read only mode. And after that, again syscall. So again, these two instructions will be executed. So this is typically what we are doing over here over here in the code. I'll put the code in the description link. No need to worry about that. So now simply let's go ahead and execute it. So here are the three commands. Okay, it's compiled. Okay, I think I missed one command in the list. Anyways, I have it here in my terminal. I have to link it. It's called ld. I'll just correct the command. And now I have an executable file called hello. So I will simply execute it, and you see I get the output as hello world. Now here's an interesting thing. So now let's say I make it hello and world. Okay. Now let's see what happens. I compile it again. I link it again. I execute it again. Now if you see, it's showing as hello and WORL. So it's printing only till here. And also over here, if you see, it was taking the new line character. Over here, it's not taking the new line character. Now, why did this happen? Because I added few more bytes in the text memory location, but in RDX, I did not change anything. So in RDX, I am still saying show it to 14. So it's cutting it down to 14 only. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So what I have to do here is increase it by 5 because there are two space characters as well. So I'll take it to 19. Now let's see how it works. Yes, now it's giving me hello and world. Okay. Okay, now one more interesting thing that we can see here. So in assembly, how we can comment code is by putting a semicolon the in front of the command. So right now, I am commenting out this code. That means this 60rx is not loaded. Now let's compile the code again, link the code again, and execute the code again. Okay, now you see here a segmentation fault core dumped is coming. Why is that happening? Because I'm not specifically telling the racks to exit the program. I'm not making it clear that the program should be exited. So the kernel has its own way of dealing with it. It's throwing error segmentation fault. So I'm not sure what kind of implementation is there in the kernel why it's showing throwing this error, but it's throwing it because we did not exit the assembly program clearly. So let's comment it out, exit it properly now. And what do we have is again a proper output of the program. Cool. That was it for this video. Stay tuned. I'm adding more videos on assembly, on front-end engineering, JavaScript, and some videos on DevOps as well. Do check out the other videos on the channel. Thank you.